display, matrix display, that is also there. You can try that. It gives color to this. So this is not colorful, that gives colors, which is okay. It looks better in if you do that way. So we have two problems now. One is we have a text data, and as you know, that text data is again so we have learned the machine learning models, logistic regression, linear regression, XGBoost, sorry, not XGBoost, but ADA boost or something like that. Any boosting techniques, trees, all the models. So you give numbers to them, like 4.5, 3.5, something like that, and they do this counting of or calculation of some kind, and then give you the output, right? So that is the thing we do. But text data is something text, it's not numbers. So in this case, how what should we do, right? So that is so this is the issue. Another is same thing with image data. So this is the image, it's not a number. So how we can process this for machine learning tasks, right? So we have some classification problem, some regression problem for this, and how we can deal with that. So it's not limited to this. Even something called speech technology is there, where speech data is there. So it's not in our syllabus, speech data, but it is also there, right? So for this kind of problem also, we have to do same thing. We convert them to numbers. Okay. Other could be image, text, speech. I think that that is more than enough. So this is not part of our course, but if you come across somewhere, it is you can use that, right? Uh, so what we have to do, we have to do some form of pre-processing of the data. So we have to convert them to numbers, right? So you have to convert text or image to number. To number. Okay. Another thing. So once we have the numbers, we are good, right? So we have numbers now. Same thing, like nothing changes after that. So earlier we had tabular data. For example, this data was there, right? So this is a tabular data. If I have this kind of data, then I have no issue. I can do anything. Like after that, usually my usual data science or a cycle of data science model building was like, let's say, what cycle I used to follow. I have data, I convert them to, so if there is some form of categorical form data, I convert them to numbers, right? So that was simple form of that. But I have features in that, right? So that was there. So now we'll decide what features are there in image and text data. So we have to decide these features after converting them to numbers. I mean, what form of conversion we should do so that I get features. Some form of features I should get. So if I have features, then that is good enough, right? And labels are, of course, will be there. Something will decide with the text data. So I have text data, lots of text data. So in that I can actually decide what to do. Like not necessarily you have to follow a path. You can take different objective also out of text data. For example, let's say you have a text data. Let's say a book data is there. Now you want to see how many times, let's say Harry Potter book is there. How many times Harry Potter name is coming into that book. So counting of name, you can do that. Now another problem could be converting your English to Hindi conversion, something like that is also a NLP problem, right? So natural language processing is what we call that problem of text, where we have text, right? So natural language processing, it has many use cases. So chat GPT currently we are using, or this Gemini we are using, right? So I just have to tell it to what code I want and what form I want. It will give it to me, right? So that is another text use case. We will not be able to build this kind of thing like chat GPT or something using just machine learning. It's a concept of deep learning and then further a very specific field of deep learning in that also, right? Um, but it starts here, like, so text data we have, and we start from here, and then now we have reached there. So it's a very good progress in form of text part. Okay. Any question? Okay, maybe.
No, sir.
Okay.
So the
So
GPTs and all come under NLP only, natural language processing.
yes, it comes under NLP only, natural language processing. Yes. Features, labels. Yeah. So if I have features and labels, then my task is done, right? So if I have that,
NL
so,
NLP is the subset of deep learning, or deep learning is the subset of NLP?
so deep learning is a uh, see NLP is a use case of deep learning or
Okay,
machine
got
learning, anything,
it.
right?
Got it. Got
It's
it.
not a part of anything. It's not like that.
Okay,
Uh, okay.
got it.
Okay, so if you have features and labels, we can then do same thing, right? So what we do, train test split, we do after that, train test split. Then I can do some feature selection. I can do, right? So feature selection, or you can say feature reduction, PCA, dimensional reduction. That thing you can do afterwards. So after that, once we have this features and labels, rest of the process remains same. Nothing changes once we have that. Okay. So, but this is the only tricky part of this image or text data or any other form of data. If you have it in numbers, then then you are all sorted, right? In numbers. That's all we have to do. So we have some techniques for both of them. So let's first just cover the text part only. We'll see text part, and then we'll see image part. So text data. So what we can do to get features and labels, right? So one of the easiest technique was, let's just count how many. If you have any, let's say I have, uh, some Wikipedia. Okay, so let's say I have this page on, let's say something like, let's say India. Okay, now this text is there. I want to let's say I have this text. Now I want to do something with it, right? So this is the text data I have, and I wanted to use for some machine learning task. Now what can I do with it? So one easier method was, we can just apply, counting. So let's say how many times something India is coming into this text, right? So say one, or you know so you can see it's coming around like 1, 2, 3, 4, 5 times it's appearing, right? So this is Indian, but just consider as of now it is India only, or something like that, right? So that is one way, like you can do counting. So Indian and India as of now, like they should be different. What we are doing in that way. So count vectorizer technique, consider them, both of them is different. Okay, it doesn't consider them same. So we have actually 2 times only India coming. So 1 and 2, or maybe 3 here, third one, right? Then we'll do same thing with the officially word, and we'll take what count it has. Okay, so like officially how many times it's appearing. I think it's appearing once only. Okay, so something like that. Now so that is called a count vectorizer. Okay. Another thing, so some improvisation on top of that is, so we are just counting here, right? So each individual word will take and will count. That is the simple thing we are doing, count vectorizer. Now the issue with count vectorizer is, so you see, so issue is that some words will obviously appear more times, right? For example, if I write the, like the should appear more number of times, right? Like in our text only. So you can see a lot of yellow color is coming up. So that many times the is coming, right? So it will have, definitely will have more count number. And same thing will happen for other, some other word is, or right? So I mean, this kind of I was talking about, where this single character, so it looks little different, something like that, and so on, right? So this kind of words will have more count than the normal words, right? And these are not very important, like and, is, the, uh, hi, he, something like that, right? So that are not much important in terms of giving you any information. So for example, if I write India, that is very important, because then you will know that this text is about India. Or let's say when China coming up, then maybe you will think that, okay, this text is maybe about China, something is related to China, Nepal, or something like that, right? So those words has some importance also in real word, right? So for example, for this example only, right, we ignore the stop words and we have some important nouns coming into picture, right? But they will have lower count. So that is the issue with it, that some uh, some words will have higher count, but they are not important. Not important, right? So something like that. So for that, there is a another technique came to as the improvement to this, that is called TF.
Single letter also counted as a word.
Yes, single letter is counted as a word.
Like a, it will take
Yeah,
as
it
a
is
word.
counted as a different token. So we don't call them as word, we call them as token. So each of this is called token. Officially, the is a token, is a, everything is a token. Okay.
Okay.
Yeah. So another improvement on this is called TF-IDF. So in that, what we do is we definitely do count thing. So that is called term frequency. Okay, term and frequency. Frequency is just count of that term. Okay, so let's say end is coming 1, 2, 1, 2, 3, 4, 5, 6, 7 times, right? So term frequency is that only. So count which we have done, right? Now something IDF we do is we take inverse of document frequency. Okay. So if I show you TF IDF vectorizer, or actually better, we go TF IDF transformer. So same thing. So what IDF does is we take log of something like DF n into, okay, give me a minute, just what I wanted to show you is so what we are doing is, let's say I have number of documents, right? So this is a paragraph on India. Similarly, I might have another paragraph also. So multiple paragraph I will have, right? And for that, some labels will be there. So this is my one paragraph and some labels for that, some label. And similarly, I have multiple corpus. So this is called, so the whole thing called corpus and each thing called document. Okay. So for each document, I called total documents or total number of documents, and I'll denote it as n, right? So small n is the one I'll use to denote that. And DFT is again same thing, right? So whatever so how many of this documents have the that term, we write that with this and we take inverse of that, like so that's called inverse document frequency, like how many times that term is appearing in how many documents, something like that. If you're not getting it, so we can take a example for that, and maybe it will clarify that. So let's say I have count vectorizer first. Count. So from sklearn dot. It should be text or something like that. Extraction from so this two I'll take and I will paste it here. Okay. Okay. So what we have to do is we can take this example. For example, this is the corpus. Okay. So this is the corpus, and you can see each of this is called document. So this is the first document. That's what it says also. But don't worry, like this is a document and second document, third document, fourth document. So total documents are total documents or n are n equal to 4, right? So that's what this this n is here in df-idf. When we'll use df-idf, that's what I meant by that. And then like term, right? So term frequency. Let's say term frequency. What is that? That is same as count vectorizer. So whatever this count of each of them will come, that is term frequency. So how will I get the term frequency of each of them? I can have let's say CV is equal to count vectorizer. Okay, and I can say CV dot fit and then do transform also of my corpus. Okay, so I can give my corpus to it and it will do the transformation. It gave me some sparse store or something like that. So let's say what I can do is I can store it as a CV matrix. Okay. And then I can say CV matrix dot to array. This something like this. And if you want, I can show it as a pd dot data frame, and columns should be. So if we go to CV, which is our count vectorizer, it has an attribute of vocabulary, right? So if we have to see what vocabulary it built, right? So vocabulary means all the unique words will be there in that. So whenever it come across a unique word, so let's, for example, this is this so it is a unique word first time, right? It will note it down. It's like we are building a dictionary of our own. Then it goes to is, and it will add it the first document. It will add all 5 of them in first go. Then it will go to second document. Now this is already it's already there in the dictionary or vocabulary. So we'll not add this. We will just skip it. Document is also there, so we'll skip it. Is the all of them are there, so we'll skip all of them and we'll go to second. So this is a new one, so it will add to the vocabulary, right? So that's what this vocabulary is in count vectorizer. So if you see the so this attribute, right, vocabulary, that you have to use to get the name of it, right? So this is the first document.
What is keyword, no? Vocabulary.
Yeah, it's a attribute. It's a keyword. You can use that.
Attribute of this count vectorizer.
Yeah, it is a attribute of count vectorizer. Okay, and these numbers are appearing. So these are like just a way it is stored, right? So 0 given to that number. So it's just giving you count. For example, if I show you how my
So,
Yeah. So for example, zeroth, right? So
how come count is appearing as a 0? Because if the word is not there, from where it is speaking this?
which zero?
And is 0 only, right?
No, no, it's not count. It is a dictionary which shows that. So it
I
is
think
just giving it a
number.
number.
I think the number of feature.
No, no, no. This is
maybe the index based on the alphabetical order and got 0. I think the first word.
Yeah. Perhaps it is
Yeah,
like
yeah.
that.
It is a dictionary index
And,
sort of.
and the eight is T.
yeah,
Yeah.
correct. So it is just saving the dictionary. Like we are creating dictionary of its own. So whenever and is coming, right? So it will give that as zero. So for example, this zeroth column you are seeing, this column, right? 0010. That is the one which gives the count of and. So you can see and is only coming and in this only, right?
The vocabulary gives the number of features of the text, right? All the features of the text. Is it?
Vocabulary is the unique words, and it is just like let's say you wanted to represent this, right? Like something with number. So what number you will use for that? So any number you can use, right? So it is using zeroth for and one
By
for
default. By default.
No. I think this is the alphabetical arrangement.
It is alphabetical arrangement.
Because there is no other word with A, so A is coming first, so and is getting 0.
Yes. It is
Yeah, you
alphabetical
can
only.
just replace one word with A and A, that will get 0, and this one will become 1 in that case, and will become 1 in that case.
Yes.
Just write AB in that, in our text, AB. AB.
Don't worry. See, don't go into that. That it's true. Correct. You are
Okay.
saying is
Okay.
correct.
Okay.
Okay,
Fine.
I agree with
move.
you.
Okay. Fine. Vocabulary is that.
Yeah. So what we have to give is, I'm not sure what is. What is fixed vocabulary, but guess not. I'm not sure what is that, but we want what we want. I want vocabulary is fine. Fit transform get features name out. I'm not sure why is. Yeah, okay, this works. So we want this as a column. So this is my data frame after converting to numbers, right? So this is like my whatever my DF was after converting to numbers, okay? Using, let's say, using counts. Okay.
Hi, sorry to cut you. Could you please also share this collab in the chat?
Okay. So that's what we did. We tried to identify each individual token, and then for each token, how many times it's appearing. For example, the document is appearing twice in this document, right? So we can go. So here you can see document and document. That's why it got 2 counts. Anywhere else, it is appearing single times only, right? So this is what a count vectorizer will do. It will give count of each token and something like that, right? Now it will assign some numbers and all, which um, which helps in identifying where this column is going to be. Okay, even if I don't convert it to data frame, I can look into this dictionary and I know where which column was assigned to what text, right? So third means, let's say document got first index, right? So that means document will appear here, or let's say this will appear at 8th position. So this is going to be 8th in this, starting from 0. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, right? So that's why it's here. So by looking at the vocabulary, you can you just get to know where each of this column are. So what does this do is, uh, first document is like this, and it has 0 and document is one's first is something, right? So we have converted the text into numbers, and each uh, individual text or each individual word became the feature of it. So now these words are features. Okay, they were earlier, they were just text, but now they have become features of the data. Okay, so for example, if we have this huge text, something like this, and for example, my corpus is something like that. What did it do? I think it worked. Okay, so something like that. Now let's say another text could be different. So just will imagine that this is a different text, and something like that. And let's say something more text is here. Okay, let's put here. Okay, now I have 3 different documents. So just see that if I show you so this is in a list form, right? So all of them were in list, like list of documents I got, and then that's how I'm doing it. If you get a data frame also, that is fine. You series is a
So
list.
each new line is created one document kind of, right?
That is not the case. So we have created a list, right? So list is separated by comma. That's what is how
Oh, okay.
It can be in the same line also.
Yeah, it can be in same line also. Yes. So for example, this I can write like this, but since this is a list, so you know what the
Yeah,
comma
if it is
separates it.
comma
Within quote,
separated.
within quote, if any comma is coming, then it would be ignored, right? It would be considered as a text kind of.
Yes. No. I mean, see, it depends.
No,
This is a list,
the
right? How
first
we write a
line, this
list.
is the first document. So if I have comma after this, then that comma would be ignored because that is coming in between two quote, right?
Yeah, that is ignored. Correct.
Hmm.
List, right? You know what is list?
Hmm.
Yeah. So this is a list. How you create a list? That's how. So in between you write anything that doesn't make any difference. Okay.
Okay, fine.
Yeah. So you have to write it in a list. Okay. So I have this list now. Some invalid text. Okay, something like that. Okay. Now I have another corpus. Now if I do fit transform of that, let's say, or let me create it from scratch only. So I'm initializing new count vectorizer and I'm transforming it to this. Now if we see what vocabulary I got, it is going to be a very huge, like compared to what we got earlier. Right. So it has so many letters to it. Okay. Now something like that. Now what we can do is we can get this something like that. This is a these are all the individual or all the unique in this, right? So you can maybe identify length of this thing. So for example, 176 unique words are there in this. Okay, so it starts from 0 and it might have got to 175 or something, right? So wherever the maximum is, or but whichever last will come, it is that, right? So this is just a counts of that. And how does my metric look like? If I wanted to show you that, I will, how many columns I will have? 176 columns I will have. Okay, so earlier I had only few columns, but 176 column is very huge. So that is also an issue of text data, that more the unique words, that many columns will be there. So later, after you convert it to numbers, you have to do some form of feature selection or feature reduction. Okay, you have to apply PCA before you train a model, because otherwise you will have many columns in this. So there is one another short way to reduce this, which is called hashing vectorizer. Then hashing vectorizer, you use some form of computer science, like system design, something like that, and you can decide how many columns you want. Okay, you can decide in that, but I don't think so we can decide in count vectorizer that how many columns I want. Decode, stop words, token, anagram. No, it's not that, right? So
max features will be there.
okay, it is that, right? So yeah, so you can give maybe max features, that many features I want. The parameter is ignored if okay. That only considers the top max features ordered by term frequency across the corpus, right? So what it will do is, whichever has higher frequency, that frequency wise it will take up to the maximum number you have decided. Let's say 10 top 10 frequency numbers it will take, and then rest of them it will ignore. Okay, it will not take that into consideration. So something like that you can do to reduce the numbers. It depends, like will it work out or not, but something you can do. Okay, so that's what count vectorizer is. And if we wanted to so let's say if I do max feature, not here but here, max features are, let's say, 20, and I see a vocabulary. So this all vocabulary is coming into that. Okay, now let's say I convert it to pandas data frame and see what is happening there. So you can see, right? So now my counts are a little different. So end is appearing 8 times, and this is coming 2 times, country, early, from in India, and something like that, right? So but you can see the higher counts are off, and by, from, in, then into, is it like something like that, right? And which are not very important words. They are called stop words. So this is called stop words. So what you actually do is you create a stop words dictionary. Again, like let's say this is you put some words into it, and is they something, whatever, like by, right? So these are called stop words, and you can actually remove them from considering the counts, right? So one way to do that is, it is given by our count vectorizer, that stop words, if you use English, then there is some default, some used, right? So what words are those? I think you have to read stop word list and free open source software. I mean, whatever coming into, right? So yeah, you have to maybe download this and see what words it has considered. In English language, some words are considered, but if you are not sure with that what they are going to take, you can definitely give a dictionary, you can definitely give a list to it, right? So it says that either you mention English, that is fine, or you can give a list, right? So list also you can give. For example, we can give a list and we can try this, right? So and by will take, let's say from also I'll consider as a stop word. Okay, and something like into or it we can take. Let's say into let it be it. So you can mention this stop words as a dictionary or a list, right? So not dictionary, as a list you can give. So let's say if I give stop words and this list is stop words. Now you can see it is not there, right? So the count of 20 we excluded all of them. Okay, so yeah, and is by from it. This will not appear into this counting. We can exclude them. So some other form of stop words will be there. Some others. So we don't know what else are there, but people have done some testing and all, and they have made a stop word list of English language. So if you are using on French or let's say Spanish, Hindi, or Tamil or something like that, then it will not work. The stop words you have to manually maybe decide it, but for English they have done it. So if we do that, you'll get some other number, right? So you can see Ego Asia. Now maybe some good features are coming out, right? Better than what we got earlier. Like earlier it was filled with and is by from it. Now we can't make any use case of that, but here I got very even better features, right? So Asia is could be a better feature. Country, BC could be a good one. Early India. Now India and Indian is also same thing, probably coming into similar line, but still okay, right? So we got these features using stop.
What is this 000?
It could be somewhere 000 somewhere there. It would be, right. So in our text 000 will be there.
Part of the text. Okay.
I think it's in the second data frame. 000 is there somewhere. So this, right? So this is 000.
Okay.
Yeah. It doesn't know. See, this is computer. It doesn't know what is there. It will consider all of that as a text. You have to decide what is a text and what is not a text. Okay. So what other thing you can do with count vectorizer is stop words is there, tokenizer, okay, fine, preprocessor, strip accent, encoding token. So something like token pattern is there, right? So token pattern means you can give by default it's using this, but if you know regex, you can change it. You can decide what kind of pattern you are looking for.
Would you copy this default one? How this is analyzing these regex, this token pattern?
So this is a regex function. You have to write a regex formula. I mean, you have to write this in a regex form. It means like a word and some binary or something like that.
Okay.
Now, what currently we are doing is we are taking one word only, right? So this is called n-gram. So lower and upper boundary range, some n character means unigram. So if you write one, that means unigram. If you write means unigram, and bigram means only bigram. So unigram means I'm taking one word only, right? One word at a time. But what I can do, I can take like two words at a time also. For example, let's say South Asia. Now this is a common word, right? South Asia. And it should be like that only. It should not be like Asia and South will be different meaning. South Asia has a different meaning. So if your text has like something like that, you can actually change the pattern of n-gram, right? So you can say, let's say 1,2. That means consider unigram also and bigram also. So if I do that, you can see some, for example, Indian Ocean is coming together, okay? And years ago, this is also coming together more number of times, because we have set max features to 20. That's why if there is a higher count, then only it is appearing. Okay, so something like that also you can do. So Indian Ocean bigram, this is another bigram. So this, right? So now bigrams are also coming into this. If you want, let's say trigram, three something. So is there anywhere trigram was used? Yeah, here, right? So 000 years ago. This is maybe having higher count or something like that, right? So, but it is considering all of them. So 00 is that unigram, then same format bigram was used, and same format trigram was used. So if you want a different way, like let's say you want bigram and trigram only, you can mention like this. Right? So now you can see it's only bigram and
Bigram in the where column count vectorizer
bigram. Sorry, what?
parameter bigram.
No, bigram means two tokens at a time.
Where we will use this n-gram.
Ngram in count vectorizer, it's a parameter that you have to set.
Okay, where we will put n-gram is equal to 1, 2, it will take 2. If it is 1, 3, it will take 3. Is it?
Yes,
Okay.
1, 2, 3, all of them. Like 1, 2, and 3. If you write 1, 3, it will take unigram, bigram, and trigram, all of them. If you write 2, 3, that means it will take bigram and trigram. If you write 3,
Okay.
3, it will take only trigram.
It
So
is
it is
range.
like lower to higher range, whatever you write, that way. It is.
Okay, okay, fine. Thank you.
Okay, so that's what is now some form of feature. I mean, feature text processing is not given to you. Like for example, called stemming, limitation, something like that. It's not there. Maybe you can read about that, but it's not important to us. So something I'll just write it here somewhere that that is called. One is called stemming. It's not important. If you wish to read, you can read it. It's for our perspective, like it's not there in our course. Something called lemmatization. Okay, so these two are just some other technique to get text out of it some other way. Okay, so that is what we do with count vectorizer. We count them and we get this. Okay, just let me change it to 1, 1 so that it becomes little easier to.
Hi, sorry. Actually, I'm still confused with this n-gram. So I do understand that, like, if it's a bigram, it will pick two
So
words at a time.
let's say your something some words are there, right? For example, which was that? For example, Arabian Sea, right? The Arabian Sea makes sense if they both are together. What if just only Arabian is written? It's a different thing. Sea is also a different thing. But we don't want that. We want both of them together. That's what makes sense, right? So this is a bigram. This is not a single word. It's made. So this Arabian Sea is a single thing, but it's made out of two words, right?
Okay, and this stuff is like already like pre-known through the sklearn that it's a two-word, right?
Yeah, so you have to decide. Are you comfort, like are you okay with just single word? Like for example, this is single tokens, right? Are you okay with that, or you want to count as a bigram? Is it like you want to go with that?
Oh yeah,
So it's a
like this.
hyperparameter. You have to try and then do it, test it.
Okay,
There is
so
nothing.
this bigram, trigram, it will be already configured by the sklearn and behind the scenes.
Yes.
Okay, we only need to specify which tokenization we want.
This
Yes.
bigram tokenization, how it will select whether it will be joining words or any words?
No, you can't select each, like you can have this here numbers and all. It will create bigram for all of them, right? But your max feature is hit. Like for example, we are setting it 20, but if I don't set it, then we go and do for all of them, right? So now you have to do feature selection in that. Is it important? So see word. Now I'm not going into what feature is important, right? So that feature importance you have to decide, but it will give you bigram for all of it.
My question, when we are using 1, 3, the unigram, bigram, and trigram,
Yes.
then whether the words selected for the features will be adjoining words only or any words it can take.
All of them.
Randomly.
All of them. No, not randomly. All of them. So it will start from here, India, right? So this is a unigram. Then we'll go India officially India officially. That is bigram of that. Then we'll go India officially that is a trigram of that. Then it will move next. So it will go to
Okay,
here.
okay. Adjoining. Okay, got.
Then officially the republic. Then that will move to next word.
Okay, adjoining. Okay.
Yeah. So it does like that.
Okay, fine. Thank you.
Okay. So that's what count vectorizer does. Now, so some issues with count vectorizer is it gives higher count to something and so on, right? So we have to decide using stop words, maybe using n-gram and something like that, right? But what if something is not there in the stop word list, but still it is not very important, right? Something like that. So for that, you can take inverse like TF-ITF vectorizer, which what it says is like what is the idea behind TF-IDF is that if a term is there, for example, let's say a term is apple, okay, apple is there, it's appearing in the first one, second one also it's appearing, and it's appearing in third one also, right? Third document, it appeared in all three of them. So that means it will give small value to it because it's appearing frequently in all of them. So maybe this is not the important identifier of anything, right? So that's what the idea is. But let's say if a word is there which is appearing in few of the document, let's say orange is there, it's appearing once in this only, and it's not appearing in this one or this one also. So maybe orange could be a good identify that maybe this might help in doing the classification, something like that, right? So based on the how many documents have this word, if all of them have same word, then there's no point keeping it, right? So all of them have that word, maybe it will not help in doing the classification, something like that. So that's why we'll use TF-IDF. So it's all the same. We have to write the same code, like almost nothing changes in the form of code. Instead of count vectorizer, I will write TF-IDF vectorizer. Okay, TF-IDF, not transform. I want. Did I import it? Transform. Okay, I need actually TF-IDF vectorizer. So transformer is something like it helps inside TF-IDF vectorizer. Okay, so just whatever we are doing inside TF-IDF vectorizer, that is all. Like that's how you write a Python library, right? So each class you create separately, and then you use it or you inherit that features and so on, something like that. So let's say TF-IDF. Okay, this is fit transform will remain same on the corpus, and maybe I can say TF-IDF metrics to this. Okay. Now let's see how many features it gives. So TF-IDF dot feature, or let's say vocabulary. We can say vocabulary. So again, it's a very huge vocabulary, but TF-IDF dot feature names out. It should have that.
Sir, get features name out.
Get features name out. Okay, so something like that. Now, if you see the length of this, it's this also 176. Okay, as of now, it is taking all of them. but it will give lower, like okay, let's see what if I say max features 20 to this also, okay, and if I see what I got, and I have same thing I have done on the count vectorizer, where I'll say max features 20. Okay, now these are some features, and these are some features. Maybe some feature will be different, but you can check what count or what values it will get. It will not get very high values if somebody is repeating in all of the document. Okay, so I have to mention this matrix to array, and then I have to give here IDF, right? So okay, so this is this values are coming into like decimals, but here it will come in integer only, right? Because we are counting, just counting, nothing else we are doing here. I don't know if I have done that. Okay, so and by country early, I guess almost similarly it looks like, but you can see the values it are getting. For example, this got 8 here, which is very high, and by got 2, right? So, but here, okay, it got high and it got low, same thing almost. Early, so here early got 0, right? So it's not appearing, but here see early got some number. No. Should get something 3, 2, 3. Okay, 0, 2, 1, 0, 0, 0, and 2. This Indus, if we check Indus, if it is there, 0 and 25 something.
Maybe it is left out.
No. So it's working correctly only, but what TF-IDF does is like, so it's according to this formula, right? So TF-IDF. And if you see, let's say DF, so this is a good example. For example, this word is there. It's appearing once, twice, 4 times, 12 times, 21, 34, something like that. Good is appearing 37 and so on, and their IDF are like this. Okay, so inverse document frequency, how many times you have to take log and so on, right? So IDF formula is something like log of total documents and how many documents it's actually appearing. So this IDF, and then you take multiplication of this two, 1 and 1.57, 2 and 1.27, 4 and 0.996, something, right? So if you do multiplication of that, you will get a lower number, right? For example, this full was appearing 36 times, but IDF value was very low, so it will lead to a smaller number of full, right? So that means it's not very important. This word is not much important if their IDF is smaller. Okay, inverse document frequency, like how many, that means it is appearing in most of the documents, right? So if you take log n by nt, let's say log of 10 by 1, 2, 3, and p dot, let's say I have array where I have some value, for example 10 by write 10 by 1, 10 by 2, is it possible? Okay, it's there. Okay, and let's say I have 10 by 3 and 10 by 4. Okay, so I have this value. Now let's say if I take np dot log of my array, you can see if they are appearing more number of times or more number of documents. So for example, I had 10 documents, total 10 documents, but a number, sorry, a text is or a token is appearing once only in one of the document, then it will have IDF value of this 2.3. It will have higher IDF value. If it is appearing 2 documents, then it will have somewhat lower IDF. And if it's appearing in 3 documents out of 10, it will have even lower, and then so on. Right? So as if a word is appearing in all of the documents, which is going to be 10 by 10, right? Like, it's like log of 1, which is 0, correct? Log of 1 is 0. So that's what like it is. If it is appearing more number of documents, then we wanted to give it a smaller count or smaller importance. So that's what this IDF will help in doing it. Okay, you can maybe read this if you are not able to understand TF IDF. So lecture was maybe even professor was able to explain it very well. Some example is given here. So how to manually count, calculate this, and so on. You can maybe try that. Okay, so this manually example is there. Each calculation they've shown it in the Wikipedia. It's there, right? So you can maybe read it. I guess I can add that. Add that to this one. You can maybe read it. So that's what TF IDF does. Some numbering and all. So these numbers are the one which we are going to use for doing the classification and so on, right? So let's say I have data from sklearn dot datasets. I'm importing news data, right? So news 20 fetch 20 news group data, and I have to, if it does return x y equal to true, so x comma y is this one. Now if you see, take little time because it is fetching from somewhere. So my x is, so my x looks like this, right? So it is like if I show you x of 0, so this is our data from somewhere like some news website it has taken from. So for from Lexton.edu, where is my thing subject, or what car is this, and some text on that, and brought to you by neighbor Lex or something like that. So this is a text on that, and if you print label for that, that is y0, that is 7, right? So we are going to classify this 20 news group data into different groups. So it's like a multi-class classification problem. If you go to that thing, you can see that there are total 20 classes are there, total 1846, like that many samples are there. Features are text only, right? So something like that. So you can actually take a subset also. You want test train subject. So by default it gives train subset only. But if you want test subset, you can take that. All of it is also you can take. It's up to you, right? So try daily, nothing much. Categories. Okay, so
So
the
what would be like document and corpus in this case, in 20 news group case?
sorry, what corpus?
Yeah, corpus and document which we were mentioning earlier.
Corpus, yeah. Okay, so this with what we are looking at is a document. So this is a document. Okay, and this 1,846, all of this, each individual news, we combine all of that. That is a corpus.
Okay, fine.
Okay, so all this news, all of that, or all X is a corpus, and each individual is a document. So this is the first document which we are looking at, and we have to convert this document into numbers, right? And all of the documents available in our corpus. We have a very big corpus, but there is a one thing we can do, which is we can so some categories we can download. For example, these categories are there: alt.atheism and sci-fi.space. So these two categories, if I want to download, I can mention it into categories, which is here, right? So I get that categories. That category is only samples. Okay, so that samples I can only render, or I only take that has that. Okay, now how will I get to know what different targets are there? Target names. Okay, maybe I can use target names. So for that I need to maybe have to call it as a say news or something. Yeah. Okay, now let's say news dot description of news. If you wanted to read about that, you can definitely do that. So this is it's a very huge description. Total 20 classes, 20 news groups are there, and these are the groups which are there. So let's say you want few of these groups, like for example atheism, graphics, and maybe this one. You can take it and mention it into the here while you are fetching that this category I want, right? So categories equal to this 3. This looks like works. Okay, so this 3 category will appear, not all 20. Like we can do all 20 also, but it's very huge, right? So in this case, our shape of x dot shape or something like that, if I or maybe length of x will be 1655, right? So I've reduced it to a little bit. So I'm now taking only 3 categories data and doing it, right? Now I have to convert it to count vectorizer or something, right? So I will create a count vectorizer. So count vectorizer, and it's up to you. You want to keep max feature something or something like that, it's up to you. Maybe we can have stop words. That is a good practice. Maybe if you have English data, then you should do it. Okay, let's not have bigram or anything. Plain just stop words. We'll go with that. Now cv dot fit and then transform it. What my x. So here it's up to you. You want to do x train, x test split, train test split or not, or you want to take. So for example, here I'm by default I'm downloading. By default I'm downloading train data only, right? So subset. Subset is train. By default it's train. You want to take test subset separately and then call it as a X test or something, that is up to you, right? So you can do any way you like. You want to train test it or something, and everything is fine. So we'll just see how to train a model, and then testing I leave it up to you. So fit transform, we just have to give X to it. It will do the transformation. Now I got this many columns, 5,000 sorry, 57,089, right? So that many columns I got. So I will not convert it to numbers and all. I don't want to do that. So what I can do after that is I can do like from sklearn dot maybe decompose, import PCA, should be PCA, right? And then apply PCA to it. So how do I apply PCA to it? And then some n components, right? So one thing is I can say n components equal to 2, or if I give it into floating number, that means 0.95. So it will sum the components till I get 0.95 of that. So 100% is 1, right? So how much variance I wanted to have. So it will sum the variance of each component until 95% of variance is captured. It will stop there. That's why this is I can try. Now again PCA dot fit, and then transform I have to do on my cv.fit transform. I think I can store it. My x count. I can call that x count. And give it here. And must be between 1 and something. Should work, right? So PCA scalar, or have they changed it? And components, if it's a floating number, no, yeah, it is there, right? So it works with floating number also. If any component is between 0 to 1, that will use SVD solver, something like that. Such that so then it will select the number of components such that the amount of variance that needs to be explained is greater than the percentage specified by n components. That's what it says. So we are correct. We have that only. Or am I making a mistake? They can mention SVD solver as full. SVD solver and SVD solver full could be this. Okay, so something is because I am passing a sparse matrix. That's what issue is. So let's say I want maybe 18 features, okay, or 20 features, something like that. Using PC, I can do that. So now I have 20 features, and let's say I call it as PCA X. Okay. Now I can train any logistic regression or models from sklearn dot model selection. No, I want linear model because this is a multi-class classification problem. That's why I'm importing logistic regression and not linear regression. I'm importing some classifier. Now I just have to say model equal to this, then model dot fit, and I have to give my PCA X as a features, and my Y remains same. Nothing I have to do with Y. So let's see how Y looks like. Y looks like 0 to something. So from 0 to 2, it will be there. And we are training, so we have trained it. It couldn't able to converge. That is fine, but we can do model dot score. Same thing I can give, and it is like okay, it's good, like 0.66 that much it was able to do a classification of, right? So same thing you can do using TF-IDF factorizer. You just need to change the TF-IDF factorizer instead of that. So let's say if I copy it till here. Yeah.
Sir, can we perform RFECV on this?
Yeah, you can do that.
Transform
That
data?
is also possible, yes.
But in assignment work, it causes problem.
No, see, let's say, okay, see, if I just TF factorize. So I'm not changing all the code. I'm just converting this. Spelling mistake. Yeah, it is. So some T capital should be there and like that. So okay, so let's say if I instead of PCA, I want to do feature selection, right? So RFECV is a feature selection thing. You can do that. So feature selection, import RFE. Now see, for RFE you have to mention some model, right? So that that is a thing. Now for RFECV I have to import some model also. Let's say from sklearn dot
Logistic regression.
which one?
We can have logistic regression.
Yeah, we can have logistic regression. Okay.
Mm.
So this is there. Now let's say I want to create a RFE this. There you go, RFECV estimator is logistic regression. Step 1 something. It's fine. So X count. So this time I'm giving. Okay, let me change it only. TF IDF. Okay. TF IDF. And we call this also TF IDF. Okay, nothing changes there. This is okay. Now I just have to change this to TF-IDF. Okay, now I'm fitting it. But I have to mention how many
Iterations.
no, how many I want, right? RFECV will I have to decide. Okay, that is estimators will split K number of features of select the number of selected features with cross validation. So it will give it domain. No issues. It will give. Okay, let it. But it will work. Okay,
Sir,
so
it takes too long time because of many number of columns.
yeah, because of that, right? We are taking one step at a time. Now, how many steps we have to take? We have to take almost a very big number, right?
So I have taken step equal to 100 for that, and it causes terminated worked error.
Yeah.
Terminated worker error.
Yeah, so you can take maybe smaller data, right? Or maybe you can start with small. So maybe you can start with max features, something, a smaller number. Then you can do if you wanted to use it. Or some other feature selection technique also you can use. For example, select K-best or something like that. Variance threshold. So something like that also you can use.
Yes, sir. RFE is working fine, but RFECV is not working.
Because we are doing cross validation also, right? So it is very computationally heavy task. Now It will
Actually,
take time either, or it might not converge in the time we have of competition.
actually, in graded assignment 1, we have to do RFE CV in a question, and
In
it always causes error. Yeah.
आर्यन हाँ चावल खाया चावल हाँ खाना बना रहे हो अब खाएगा चावल
where was I? Was graded assignment.
And I have used
Which
and jobs.
question?
Yeah,
Which-
last question. Yes, sir.
Okay, last question. RAVCV with logistics, step 100 and jobs. How many features got selected? It's not working, is it?
Yeah, because a final pre-processed data set has 5,015 columns. I think that's why it causes error.
5,000.
15
Hmm.
after doing all the pre-processing tasks. It always says terminated worker error.
Okay, I'll check and let you know. So what can be done? I'm not sure of how to. So you are writing this also, right? And jobs equal to
Yeah.
one.
All are taken. Logistic regression is working fine, but RFECV is not working.
Okay.
Is it possible?
I'll check and let you know. Okay. You can.
Yeah. Okay.
Okay, fine. So yeah, so that's what is about text data. So
So here it is working in your case,
what is working?
RFECV.
I stopped it, right? I guess it
Yeah.
was taking long, so I stopped it.
Yeah.
Yeah. So what we have done so far is that if we have text data, we can use some form of
Image
vectorization technique.
Yeah.
Right, so vectorization technique, for example, count or TF-IDF. So one more is called hashing. Is there hashing vectorizer that also you can try? Okay. So it uses some hashing technique. It's little complicated. If you have done maybe CS or something, then it's a part of system design. Hashing and hashing techniques, right? So it's like so it uses some division modulo method and then it does it. Okay, you don't need to know it, but if you are interested, what is that? You can maybe watch some other videos and you'll be able to get it. So that is another vectorization, which definitely. So text to numbers. That's what the task is, right? So text to number. Once you have the number, the game is in your hand. You can do whatever you want. So some feature selection or reduction you can do something, and then you just have to train the model, right? Train the model. That's all, right? So it's a very simple technique. You convert to numbers to some other pre-processing, selection, reduction, and then train the model, and you have the model. So you build a model with the steps. That's what the summary is about text data. Now we have some 20 minutes. We can consider, we can take image data also, because it's the same thing, like image data. Same thing we have to do for that also. But some changes are there. Like now, what are the problems with image data? We can take that. If you have any question for text, I'll take it. Otherwise, we can move to image data. Okay. So maybe I can move to image data. Okay, so what kind of issues can happen in images? So while capturing the image, right? So capturing the image or taking or storing the image, something like that, right? It might have different sizes, right? So the issue is the different size. Okay. Now, if we see this data, which was MNIST data, right? So df equal to pd dot read csv, and I give that. And if we see the df, okay. So this is this was, if I remember correctly, this was train small something. It was a image data, right? I think that's what it was. Header equal to false or something. Header equal to okay, so let's say df dot ilock and 0, and I don't want to take 0th row, and I'll take only from 1 to rest, right? So these are my features, and the first one is a label, right? So I guess this is an image data, and if I want to show you, or sorry, it's a digit data, so some digit will be there in this. Now I want to show you, if I want to show you import from import from matplotlib pipe.import plt. So I want to show plt to dot im show digit, but I have to reshape it, right? So this is correct. So you can see this is a 6 image, right? So this is an image currently, and but we are getting a data in CSV format. That's how they have given to you. So to make your life easier, they did all of that for you, that they are giving you in form of features, right? So currently you can see this, each of this 1 to 784 are actually a feature. They contain some numbers into it, and that's what make it as an image of 6, right? So now we are going other way around. We will not have this CSV, but we will have an image, right? So for example, if I have some image, I can download any image, image of let's say this image is there. I don't know if I can download this. Save image. I'm saving it. No. Download.
Right click on the image itself.
Yeah. So okay. So this is there. Let's say I want to download this. I can do it. So I have downloaded this parrot. There's a parrot image. I'll just upload it here using the upload This is called Macau. Okay, this is a Macau. So the parrot. It's doing that. Right, so you can see I have this image of JPG format of this Macau. Right now,
Whether the image should be JPG only or ping.
no, it works PNG or what format you have. So it's as of now it's an image, but we have to convert it to numbers or something like that, right? So this is the image. Now, so we have kind of like this 6 image you're seeing. We have that, but we wanted to go backwards. Like we wanted to have a CSV of that, right? So we have to convert that. So for that, what you can do, you can use maybe some libraries of Python, which will help you. So say image is equal to copy path, or I'm just writing image path equal to this. So this is my image path. Now the library which we can use to do that is called pillow library. So pillow Python library, right? So it will help you in some imaging thing, right? So if you have image data, you can read a documentation or something which will help you in documentation, right? So maybe it will help you in how to load an image, something. Right? So very basic thing we needed, like image module is there, which will, right? So from PIL to image, then with image.open, then give your image, and it will show, right? So here it is doing rotation, but without rotation also you can see. Okay. So like so let's say if I write will it work? Yeah, so PIL is supported by default. You don't need to do that for our, right? So image.open, and then I have to give the path of this, right? So image path, which I have mentioned there, and it will open the image for me. How big is this image? Not sure.
Sir, if dataset has too many images, then we have to zip the images. Yeah?
Then I mean, so uploading is the task. After uploading, you have to unzip it, right?
Yeah.
So
Sir, in graded
in a
assignment.
folder.
Okay. Yeah, in graded assignment 8.2, I am unable to unzip the file. I don't know how to download the data set. It is downloaded, and but when I compress the data, and here in Colab it gives error. It says zip file is corrupted. It is not valid zip file.
Okay, it's
Yeah, I have done this. Yes.
So you're saying it's a corrupted. The thing you can do is you can upload it to the drive and then connect your drive to it. You can try that. So connect your drive and then load. So you can see this option, right? This mount drive. If you do mount drive, you can go there in your drive, and you can simply like path of the folder, right? So here you can see directly folder coming. It will show folder from your drive.
We can take two big file here in Colab.
Yeah, you can do that. So go to your drive and upload this zip file to that. and then you mount your drive and take it from that. So for example, if I go to drive, and I upload my file upload I will do, and I'm uploading the one I take, right? So archive.zip is the one. I'm not sure how much time it will take, but so meanwhile I'll do the mounting of drive, right? So mounting drive, it will ask me to connect. I'll connect it. There is a code for that also. Sometimes code appears, sometimes it's not. Don't worry. Like anyway, like we just need to do the connection, right? So now I am in the drive. I'll go to my drive, and then I have to search for it, right? So it's that is the problem. Like this is a very big thing, but if you know where your file is, you can definitely like you won't have that many things in your drive, right? So you will be able to identify it. Now I wanted to have.
Sir, have you downloaded the file?
Yeah, this is the one, archive.zip. I've downloaded that. So this one, this archive.zip. I've downloaded, I uploaded it into my.
But downloaded in which app? It asks for the apps for zipping.
It doesn't ask for app for zipping. It's already zipped. Zipped, right? So I just need to download that. That's all. Download, it's in the zip only, .zip. I uploaded .zip only, same folder, nothing. I uploaded zip file only.
Okay,
Right, so it's here. You can see it's here. Shared with me. Okay, no, I don't want that, but so my drive, if I go and if I check, okay. Yeah, here it is, right? So archive.zip, which I have downloaded and uploaded it here. Okay, archive.zip. Now I just need to.
But in my drive, it is not zip file. It is only data file which has some images, mask or unmasked.
No, but you have to upload zip file, right? Otherwise, how will you? So if you have folders, that is also fine. No issue. You can do that, but it will be little different than how we are doing it.
Because when I click the download, and then archive, it says archive.zip is too large for Google to scan the virus. Would you still like to download this file? And download anyways, I clicked and I got only data without zip file.
No, you will get in zip only, right? So, it says download anyway. I mean, it doesn't say that it will convert. Like, so archive.zip only it will download. It will not download in folders. So inside it, folders only. It's see in zip file there are folders. So you know what is zipping, right? Folders are
compress
there.
The data. Yeah.
You compress it and make it one file. So if you have multiple folders and you want to keep it together, how will you do? You will zip and keep it together, right?
But
so see, just do one thing. Download it, whatever it is. So see, to me it's also showing download anyway, right? Too large.
Yeah.
And so I downloaded it. It gave me zip file. I uploaded that here in my drive.
But in my system, it gave data file. Data has two items, mask and unmask. And both has JPG images.
Then rezip it. There is, or you can re-download or rezip it. Which system you use? Linux or Mac or Windows?
Mac.
Probably it's due to Mac. I'm not sure, but then you can rezip it. Okay.
Okay.
Create a zip file of that, of your folders, and then upload it.
I did compress zip, but it creates problem here in downloading, in uploading in the collab. It says zip file is corrupted. It is not valid file.
Probably issue of Mac only. I'm not sure how what can I do? So I've already uploaded it here. To give you a link, it's the same thing. I don't know what else I do. I have to give your data. Maybe try Jupyter Notebook. Try Jupyter Notebook, not Colab, but try in Jupyter.
Okay.
Locally, you can try. So it's an issue of Mac. I'm not sure, but if your folder or something, you can do it. You need to have it in some place, right? So it's not corrupted. See, we can do it. So I have a zip folder, right? Now what I have to do is I have to copy this path, my drive, and then I have to mention the archive.zip. Right, so this is the one. And what I'll do is I'll unzip it. So I'll write that, and it is unzipping. It's inflating all of it, right? So I have my.
So simple.
So now what I'll do is I'll have it in form of. Let it create it first.
This exclamation mark is working. Exclamation unzip.
It's a Linux code. So in Linux you can use. So collab support all the Linux commands.
Okay.
Okay, so I guess we are done with unzipping. We are. I guess it's data, right? So this is the one. Now copy path. And now what you have to do is you have to call something called import OS. So OS is like again Linux only, but Linux commands, right? So OS dot something you can use to open or get the path of it or something like that. So OS dot one of the important like something called file path or OS dot path path directly could be so type get, so we have to get the directory or something, the path of something. So this path will help you in getting like what is that, right? So OS dot path. Not sure if it is the one. We was trying something. Had this cat data and also there. We have to write something like OS path, OS list directory. Right? So this is list directory is the one is command. So if I write OS dot list directory means whatever is there inside, show me like what folders you have. So this will help you in getting your folder, right? So now we are into this folder, os.list directory. Now this is a main folder. Go inside. So generally, how the storing of data happens, that's what makes this important. So generally, when we do image classification, okay, what we do is we keep we keep different class images in different folders. Okay, different folders. So that's why this is an important thing. Like we first see how many folders are there, right? So this list directory will tell you how many folders. So there's only 2 folders are there. That's why it is a binary classification problem. If there are multiple folders, then it's a multi-class classification. Okay. So that's why, like generally, this is the norm which is followed, right? Otherwise, how will you know what class is there? Maybe reading a name of the file could be option, but that is a difficult problem. Like generally, this is the format being used. So don't worry. Like you will always see, or you will always come up with this format only. Like different folders will be there inside different class things are there. For example, this cat versus dogs data. If you download, you can see there are 2 folders, right? Cats and dogs. Maybe another image classification. If you image classification, let's say Cypher 10 something is that. No, we needed data sets on computer vision. I will choose as of now human face emotions. You can see angry, fear, happy, sad, surprise, right? So that's how each folder contains each of that data. And we see any other, let's say agro paste something, right? So image data set for crop paste detection. So you can see train set is there. Inside train set, images. Okay, some image is there and some label is given to you. So already labels is given. I mean, if label is given, then there is no issue, right? So how you create this, but generally this is how it is created. You create a folder name of that class, and then inside that you put images of that, right? For the facial emotion recognition, same thing, angry, disgust, fear, right? So that's what we have. We have folders and something like that, right? So this will help us in getting the path of that. Now we wanted to go into each of this thing and then get the image of that, right? So how
this os.list dir will
Yes.
show the folders of the data folder.
Folder of any folder, right? Yeah. So what is there? Like for example, if I show you just content,
Yeah.
then we have config data, then this Macau JPG, then drive is there, sample data is there, right? So
Yeah, it will show the folder of the bracket content, right?
yeah. So I wanted to see in that data. Now we can, if I wanted to see without mask, I can. So I'll have whatever is there inside it. So all the JPG image and all. So, but this is just listing of all the directory. That's all. Like
Okay.
if you wanted to have this data somewhere stored, you can have it.
Okay.
Now, if you wanted to take, let's say, image of that, any image, right? So images, you can give image path, right? So image path is like yeah, for example, this path, if I take, I can write it, right? So if I wanted to write a loop or something, then that's a different thing. Then I'll use same like so if you have seen the video of the course, you will know that how to write the loop and all. But it's like it's very you can do.
Now image path can be opened by the open command, right? Image dot open in the bracket image path. It will
Yes, correct. So image is the one which I have imported. So I have imported using PIL. That image I have to use. Okay, just for clarification, that this PIL I'm using. Then open image path. So again, it will open this image. Okay, this is the image.
Okay.
Now, if I wanted to, so this is just an image, right? Now I want to have it in numbers. So how will I convert it to number? So that is very easy. I just have to say np dot array and then give my image. So I opened it using PIL, and if I give that, I have this data, right? So you can see this data is coming. Okay, so
Yeah, how this is chunking?
because it's a RGB image. What is RGB images? You have this. So this is a 350 cross 525 into 3. So this image is a 350 cross 525, and there are 3 of this width. One is for R, one is for G, and one is for B. Okay, so
Okay.
that's why it's coming like that. If I
If the image would not be of this size, then it will not break like this.
So whatever size is there, it will break like that. Yeah, it's just a. So if we have different image, then it will break like that. No worries. Like this is not the important part. Why it is like
Okay.
this? It's not
Okay.
the important part.
Okay.
The important part is that there are 3 channels to it, right? So this 3 is mentioned here is important, and this width and height is important. That this is what we are. Because these numbers are going to be anything. Like so, for that this image to appear, some numbers are there in the background of R, G, and B colors. Of R, G, and B colors, and if you combine them and write it in a matrix of 3 dimension, you will get this image. Okay, that's what this is. So converting to numbers is very easy. Like, all right. So what is the issue? Like, for example, if I say this is an image and give img to it. np.array, or should I write to array? Is there any mistake? I'm like G. Let's say
Perhaps it is flattened.
mg array img array. It should. So this data is showing like this only, but fine, whatever. It could be that only. Now let's say if I want to see the first img array 0 of that, which is a very huge thing. This is 60, but if I want, yeah, so some numbers are there. Okay, don't worry. Like we don't have to actually care about that. I am just trying something. We don't have to actually care about that. What we have to do is we have to find what is the highest value in this. So something that is important. You can use np.max or something. So 250 is the highest value in this, and I'm sure that the minimum value is going to be 0 only, right? So I don't actually need to run it, but for your sake, I'll just do it somewhere, right? So 0 to 255, this data is there. So each pixel contains some number between 0 to 255, and that's what makes it as an image. Okay. RGB colors are there, 3 tensors are there, and so on. So RGB tensor. It's called tensors, something like this, right? So this is the image. Some color of blue have some numbers, 7, and so on, right? So that's how this is. This image is there. Same thing we have, nothing different. It just have some different values. Okay. Now you just have to load all of the images and so on, and you have to do that. Once you have the numbers, you can convert it to this part. Right. So like we did it from image to numbers, you just have to do what? Flattening. That's called flattening command. You can give that. So for example, I can have from PIL flattening is there, or G array dot flatten, and yeah, so this is a flatten, right? So I got a vector out of it from that, right? So now I have a vector, and it has what feature? How many features will be there? It will have, as of now, it will have 350 cross 525 cross 3. Okay, but that many I won't require. So as of now, it is 350 cross 525 cross 3. But there is one important issue with that. That is that what we are trying to do a classification of, right? We don't need this 3. I mean, if we convert it to grayscale image, that would be much better. So once we have it in a grayscale, we don't have to deal with this 3, and just like enough of that is good enough, right? So let's say this mask image is there. Now, where was it? Somewhere. Yeah, so this mask image is there. Now the mask is there or not, it depends on the size of it, right? Let's say mask, what color is there, it doesn't matter, like blue, or what if the white mask is there, or what if yellow mask is there, does it matter? No, right? So we wanted to identify if mask is there or not. So mask, the shape or size or something like that matters than colors. So colors are not important, so we can convert it to grayscale image first. So what we can do is we can say dot to PIL image to grayscale, something like that. Image open, then we can say image dot convert, right? So we can write dot convert and then L dot convert and then L, and then we say flatten. Okay, if I has no image array, okay, no issues. What we can do, we can have it here. So we'll have converted to grayscale, then we'll convert it to this. Now image array is this gray, right? So it's not colored, it's gray, same thing. Now we can convert it to this flattening, right? Now we can do the flattening of it, and we will not have this 3, right? So just 350 plus 525 will not have this 3. And this is the image. We can do flattening, and I have this many elements in that. This are feature of that, and I can use all these features for doing the classification. Now, what issue could happen is, the issue could be that my size is not consistent, because that's how I have captured, right? So depends on who captured the image, how they have stored it. Depends on that, right? So sizes might be different. So you have to decide some size, any size. So it's up to you, right? So what you have to do is decide some size. Okay, whatever, it's up to you. So let's say 128 cross 128, 128. You can decide that and crop it, right? So take 128 cross 128. But from center it will take, and then it will crop it. So rest of it will be removed. So that thing you can do. So this cropping operation you can try. So I'll show you the one which we have in the lecture. It's it is there in the portal. I don't have permission. And I'll so if you see this, this is a cat and dog image data set, right? So you can download it here. It's there in the Kaggle, sorry, it's collab link is there. You have to get the directory name. Then for each class names, right? So different directories will be there for each class, right? So I'm storing each, calling it as a class name. And then for that class name, I'm joining them, right? So OS path join will join this thing. That's all. Like, let's say if I'm going inside a folder, it will go inside and just add it as a path, right? So class directory, that's what it is. Then sorry for the image name in this. Again, I'm taking a path of that. And what I'm doing here, opening it, resizing it to something, right? So resize to something is what you have to do. So we so we have this image, right? Grayscale image, which we converted to where was that? Yeah, converted to grayscale. Now I can actually do resize it to something. Let's say 128, 128. I just have to mention that. And resampling bilinear could be if I just first resize it and then convert it. Size, it's not working. Resize something, I have to go. It should work. Image path, I'm opening it and then resizing it, giving some size. Oh, it should be in a tuple. Okay, so that's what a mistake is. I'm giving it as a two different values, but it should be a tuple. Okay, that's all right. So converted it to grayscale. Now, if you see the array, it is very small, right? So now it has become smaller than this. So it has resized it. Could be like some of the elements could have cropped or something like that. Image below image resize. So new width and height in pixels, resize method. So I think it does crop it only, but I might be wrong also. So but it converts to the one which we desire, right? So 128 cross 120, anything, whatever you desire, you can convert that. So that's what the task is like. It's easier. So for each file, you do that, you convert it, then you scale it, right? So you scale that, and finally you will have all the images of numpy numbers and then labels of that stored. So because you have stored each class name also, right? So image array you are storing here, and labels you are appending to class names of that loop, right? So inside loop you are doing that. So you have this thing, you get that, then you do the train test split further. So it's already, I think it's already flattened, right? So we have done the flattening here. It's already in the list in form of it's in form of CSV kind of data, right? So data frame, we have it in data frame. We just need to train the thing later on. Okay. So train it, and then you get the labels and something. So one deviation or one variation of that is you can do something called augmentation. Augmentation is you have the same data, same file, same image. You change it orientations, something you change it in different ways, so that the model will think, or the machine will think it's just a different image, right? Because how model learns is it's let's say this is a feature, right? So first pixel of this image is a feature. It got 50 value, then 100, then 180 something. So it will think this feature is getting something like that, right? If I rotate it by let's say 180 degree, then some different value will come here, and that will go to first feature. So so model will think it's a different image in different way, and for that label is cat or whatever, right? So it's completely different image for a model. It doesn't know that it's the same image in a rotated way. So it just learns same in different way, right? So it doesn't do overfitting of the same data and so on, right? So we have more data we can train on for better improvements of that. So that's what augmentation is. So you rotate it, you flip it. Some other forms of augmentations are also there, but as of now, rotation and flipping is good enough. Others are very little complex in nature, but rotation is what you can do. Or flipping is not good, but that's also you can do. Okay, and then you can build a model. So training a model, and you the rest of this process remains same. So you are training it, and then you are doing a classification report, how much accuracy and all thing you are getting. Okay, so that's all is there in the image part. Just need to convert it to numbers, and after that the process remains same. So nothing changes after that. Okay. Yeah, so that's all I have. I guess we are about time also, but if you have any question, you can ask. Okay. Any questions, anything, or we can close? Okay, then we can close. Okay, bye. Good night, everyone.
Thank you. Good night. Good night.